Hi-ho neighbors, and welcome to Module 1, Unit 2, and we're going to look at a little bit of Lesson 3. It's going to be a couple parts, but we'll do some of it in class. We're going to solve by factoring. Just going to bring the solving in because that's really where we're going to be going to. And as it states here, completing the square is what we want to look at here in a moment. So we're going to get to that in a moment. Hang on your horses, and here we go. Alright, so according to this, we take a look at this polynomial up here. And I take a look. I got x squared and all that times this one, this trinomial times this one. And then we want to know the degree of the polynomial. And usually it's the biggest thing in there. But we got multiplication here. So the biggest thing is going to be x squared times an x squared. So if we actually multiplied this out using tabular, we would actually come up with x to the fourth. So your degree is actually a 4 on this case. And what does that mean in potential solutions? Well, we've talked about this before. Whatever the degree is, that's how many solutions you can have up to. So we could have 4 solutions as well. So moving on into this, let me take a look here. It says we can solve this whole thing by factoring, and we split the two up. So if you take a look here, I've got this one split up and this one. So these two pieces. So we're going to come down here and we're going to actually factor this. So you got a trinomial, no GCF. So on the first one, we try splitting it up into 2. And we know x squared is x and x. And we bring down the minus sign, and the boss right there, right here says it's going to be the same. So that's going to be a minus sign. And of course, the only way to get 3 is 3 and 1. And guess what? Whoa, they add up to 4. So that works out nicely. So I factored that one. Then I go to the other one here. And now it's another trinomial, no GCF again. Set it equal to 0 here, x and x. And bring down the plus. The boss says different, so I got to have opposites. Factors of 5, there's only one, 5 and 1, and they do subtract to 4, so the 5, bigger one goes first. There we go. And if you remember back to 9th grade, once we did this, and we did all that factoring, so we could do something called a t-split. And we're going to get to that a little bit more. Right now, I just want to refresh your memory on this. So we take the one factor equal to 0. We take the other factor equal to 0. So over here you add 3 to both sides, and voila, you have an answer of 3. On this one we would add 1 to both sides, and we get an answer of 1. But we add another pair over here, and this also needs to get factored. So you'd have the x plus 5 equals 0. Subtract the 5, you will get a negative 5. And on this one here, x minus 1 equals 0. You will get an x equals 1. So when I get done, I actually have, if I take a look at it, I got an answer of 3, an answer of 1, an answer of negative 5, and then this is a second answer of negative 1. So once again, we said we could have up to, way back up here, we said we could have up to 4 solutions, but since these two are the same, we really only have 3 solutions. So my 3 answers are basically a negative 5, a 1, and a 3. So there's 3 different answers on that. And then later on, when we talk about zeros, we'll tie it in, and you'll remember like a graph type thing. And if you actually look at the graph, the thing, and we'll learn all kinds of ways, but it crosses at negative 5, it crosses at 1, and it crosses at 3. So maybe something looking like this as far as a graph goes. Who knows? I'd have to look it up, or you throw it in the graphing calculator, that whole original problem way up here, and you could actually find the zeros. So this is all the stuff we did in 9th grade, and we're going to come back and do it even more in depth here now in this one. So let's move on to something else that ties right into this, because what happens if the stuff is not factorable? This case, obviously everything was. Let's start looking at the cases where they're not. So where they're not factorable, in this case here, I start to try to factor it, that type of a thing, and I do x and x, and I go and I've got a minus, and then this one's got to be the same minus, and I need factors of 3 that add up to 6. So guys, the only way to do it is 1 and 3, and 1 and 3 is never going to add up to 6. Therefore, that is not factorable, okay? And if I try the other side as well, we'd have to fool around with borrow and payback, but trust me, at the moment, not factorable. Now, when it is factorable, it's nice. We just factor it, we t-split it. All the methods we did, borrow and payback, factor by grouping, normal DOPS, whatever, GCF, all the methods. When it's not, we're going to go back to something like this called completing the square method. And if you remember that, all I do is this. I've got that x squared minus 6x plus 3 equals 0. And when we were in 9th grade, we took this, the first two, we wrote it down. Then we left some space, and I put the plus 3 over here, and this was before we got the equals to 0. All right? And then we took something like this. If you remember, we take half of the b right here, take half of this, because remember, it's the old ax squared plus bx plus c, okay, equaling 0. So we take half of that. And we said, well, that's a minus 3. So we take half of the b squared, well, take half of the b. And if we divide it, we actually square it. So what's half of b? It's a negative 3, and I'm going to square it, and we're going to deal with that. So I always wrote down, hey, negative 3, bring it down. And then we turned around, we brought it back up by squaring it. So what happens is you'll get a positive 9, is what we added on there. But we just changed the problem, so if you remember, we also then did the opposite, a minus 9. So I've got x squared minus 6x plus 9 minus that. Then we had to factor these three, and we dealt with these two separately. Well, if I factor this, it actually turns out to be an x minus 3 times an x minus 3. And when I always did it, I put it down there. And then these two come out to be a minus 6 equals 0. And that's how we did completing the square as far as that piece goes. Well, we weren't done then. If you remember, we turned around, then we moved the 6 to the other side, like that. And I got x minus 3 squared equals 6. And then we turned around and said, hey, we got to get rid of that square, so we take the square root of this side. And we took the square root of that side. And if you remember, the old plus and minus. So when I took the square here, the square root here cancels with the square. So you just get x minus 3 equals plus or minus square root of 6. 6 we really can't break up. 2 and 3, there were no buddies, any of that stuff. It's not a perfect square. And then the last step we did was add 3 to both sides. So when I add 3, we end up getting an answer called x equals 3 plus or minus radical 6. Which means you really got 3 plus square root of 6 is one answer, and 3 minus square root of 6 is one answer. So there's two answers. Problem is we got one more piece here, and I'm going to need a little more room, so I'm going to go to another page to conquer that. Alright, so let's take a look at the other half, the hardest one here. And basically we got this equation, and the biggest thing that causes a problem is this 2 out in front. Okay? So the easiest way to deal with this is let's divide everybody by 2. That way it makes it all fair. Well, that means you get down to x squared now, minus 4x. Whoops, my bad. Let's undo that. And we actually get a minus 2x, my bad. And then a minus 7 halves, I'm going to space that out, equals nothing, because 0 divided by 2 is still 0. Then we follow along our normal completing the square. I take half of negative 2. And of course that is a negative 1. And then I bring it back up by squaring it. Okay? And that's a positive 1. And I got to do the opposite, which is a negative 1 in there. And then I rewrite it. I just put the x in here, put it in parentheses. There's the square part. So that's what this whole thing factors into. You can try all day, but it's an x minus 1 times another x minus 1. And then these two here, you got to remember, this negative 1, another way of writing it is a negative 2 over 2, isn't it? Because if you divide 2 by 2, you get 1. So what's a negative 2 halves here and a negative 7 halves? Well, that turns out to be a negative 9 halves, and equaling 0. All right? So then you add the 9 halves to both sides, just like so. And I get x minus 1 now squared. Sorry, that's a 1 there. Equals 9 halves. We take the square root to get rid of that square root of this side, remember plus or minus. So that comes out x minus 1 because the square root and the square cancel. And they equal plus or minus square root of 9 halves. Well, we got to deal with that still a little later in this course. But I'm going to leave it that way for now, and we're going to just accept the answer the way it is. And I would add 1 to both sides. Remember, I cannot add this 1 right here into this square root unless it came out as a nice number. So I'm not going to deal with that. So I end up getting x equals 1 plus or minus square root of 9/2. And like I said, we're going to deal with how that looks later. And remember, on the other page, we had x equals, I think it was something like 3 plus or minus square root of 6. So we've got a grand total of what? 1 plus this thing, 1 minus this, 3 plus this, 3 minus that. So we've got a grand total of 4 solutions. Okay? I'm not worrying about the solutions as much as looking at that, completing the square. And once again, it all comes down to this. The negative b, or not negative b, take the b divided by 2, not negative b. And we got to square it. So you take half the b, divide it by 2, and then you square it. So that's what happened in this case right way back here. We got half of -1 is, or -2 is -1, and then we squared it, and we brought it up here. Okay? All right, we're going to talk more about this in class because it's been a while since you've done completing a square, and we're going to need to work on this a little bit. Versus quadratic formula, that's a lot easier, I think, for most of you. All right, see you in class.